Welcome back to Demolition Worker. Today we tackle a massive challenge at a damaged and highly pressurized well in Avaz oil field. Leaving the familiar steel structures of the refinery behind, our crew ventures deep into the scorching and unforgiving desert landscape of Iran. The Avaz oil field stretches endlessly before us, hiding immense subterranean power beneath its dry, cracked, and sun-baked earthen surface today. We are approaching a severely damaged wellhead. The twisted metal stands as a stark reminder of the violent forces trapped deep underground. This is not a standard demolition job. We are facing a highly volatile situation where one wrong move could trigger a disaster. The wellhead is completely deformed, making traditional shut-off methods entirely impossible. We must employ a complex procedure known as well killing. Killing a well involves forcing heavy fluids down the pipe to overcome the massive upward pressure of the escaping oil and gas. You can hear the deafening roar of escaping gas here. The raw energy of the earth is desperately trying to break free. Our specialized demolition and containment crew arrives on site, bringing heavy equipment designed specifically for these extreme high-pressure blowout scenarios today. Massive high-pressure pumps are carefully positioned around the danger zone. Every piece of machinery must be flawlessly secured before we begin. The twisted steel of the wellhead looks like crushed aluminum foil, demonstrating the terrifying power of the uncontrolled pressure from deep below. Engineers carefully inspect the compromised structure from a safe distance, calculating the exact structural integrity remaining in the heavily damaged metal casing. We must connect our heavy pumping lines to this mangled mess. It requires absolute precision and nerves of steel from our technicians. The core of this operation relies on a specialized and extra heavy mineral mud designed to push the raging oil back down. This mud is much denser than regular water. Its immense weight is our primary weapon against the furious pressure of the reservoir. Mixing this heavy mud requires precise chemical engineering. We blend barite and other dense minerals to achieve the exact required specific gravity. The mud is too light. The subterranean pressure will violently push everything back upwards, causing a highly catastrophic environmental blowout immediately. If the mixture is too heavy, it could fracture the delicate underground rock formations, creating entirely new and highly unpredictable leakage paths. The margin for error is practically zero here. Our lead engineers double-check every single calculation before authorizing the massive mixing process. Giant agitators churn the thick and gray mineral mud. It looks like liquid concrete ready to be forced into the deep earth. Workers in heavy protective gear carefully drag thick and reinforced steel hoses toward the screaming wellhead, fighting against the intense desert heat. Connecting the high-pressure lines to the deformed flange is incredibly dangerous. Sparks must be absolutely avoided in this highly flammable environment. Special non-sparking brass tools are used to tighten the massive bolts. Every worker knows that their life depends on these connections. The heavy containment manifold is finally secured. We now have a direct pathway to inject our heavy mud straight into the beast. The command center is a very tense environment. Screens display real-time pressure readings from the wellhead, showing dangerously high atmospheric levels. The start signal is given. The massive diesel engines of the high-pressure pumps roar to life, shaking the ground beneath us. Thick mud begins to flow through the reinforced pipes. We are slowly introducing our heavy fluid into the highly pressurized well system. Almost immediately, the earth violently fights back. The oil and gas reservoir resists the intruding mud with thousands of tons of force. The heavy, solid steel pipes begin to vibrate violently. You can visually see the immense kinetic energy transferring through the rigid metal. Our pumps quickly increase their output. We must maintain a higher injection pressure with the upward force of the volatile underground reservoir. The vibration in the pipes becomes a terrifying blur. Advanced cameras capture capture the intense mechanical stress placed on every single metal joint. Iranian engineers stare intensely at the analog pressure gauges. The needles are hovering in the extreme red zone, indicating highly critical danger. Sweat drips down the face of the pump operator. He carefully adjusts the throttle, trying to find the perfect and safe balance. The epic battle between the heavy mineral mud and the volatile crude oil is happening hundreds of meters below the desert surface. We are literally trying to put a liquid cork into a highly explosive bottle. The tension in the air is incredibly palpable. Suddenly, a massive pressure spike hits the manifold. A loud, metallic groan echoes across the site as the pipes strain against destruction. The entire team holds their breath. The safety valves hold strong, proving the exceptional quality of our specialized high-pressure containment equipment. The heavy pumping continues relentlessly. Thousands of gallons of heavy mud are being forced down, slowly compressing the angry gas and oil. We are very closely monitoring the return lines. If we see mud coming back up, it means we are completely losing control. So far, the deep well is swallowing the mud. This means the heavy fluid is successfully stacking up inside the vertical casing. The hydrostatic pressure of our mud column is steadily increasing. It is a slow and agonizing process of fighting nature with physics. The chief engineer constantly recalculates the total well volume. We must know exactly how much mud is needed to reach the bottom. The roar of the escaping gas seems to be quieting down just a tiny fraction. It is the first sign of progress. The pressure gauge needle finally twitches. It drops a single millimeter. The heavy mud is finally starting to overpower the subterranean pressure. We absolutely cannot celebrate yet. A sudden gas pocket could still blow the entire column of mud right back into our faces. The massive pumps maintain their deafening rhythm. The crew works in synchronized shifts, ensuring the continuous flow of the heavy mineral mixture. More heavy bags of barite are ripped open and poured into the mechanical hoppers. The beast underground is incredibly thirsty for mud. The scorching sun beats down mercilessly on the Avaz oil field, adding severe heat exhaustion to the long list of operational hazards. Despite the brutal conditions, the demolition crew remains entirely focused. Their absolute professionalism is the only thing preventing a massive environmental disaster. We finally passed the halfway mark of the calculated well depth. The downward force of our mud is now substantial and growing. Violent shaking of the high-pressure injection pipes gradually begins to subside. Fluid flow is becoming smoother and more stable. The analog pressure gauges show a steady and consistent decline. The heavy mud is successfully capping the volatile reservoir deep beneath us. Experienced engineers exchange cautious glances. The critical phase of the kill operation is nearing its end, but absolute vigilance is still required. The indicator needle drops further. The immense upward force that twisted the solid steel wellhead is finally being pushed back into submission. We are now injecting the final few barrels of our specialized mud mixture to ensure the deep well is completely dead today. The massive pump engines are slowly throttled down. The sudden quiet on the site is almost as shocking as the previous roar. The pressure gauge needle finally rests at absolute zero. The damaged well has been successfully killed. The beast is finally asleep now. A massive collective sigh of relief washes over the entire crew. They have successfully tamed one of the most dangerous industrial hazards. With the well fully neutralized, the actual demolition work can safely begin. We must permanently seal this dangerous breach in the earth. Heavy yellow excavators roll onto the site, their massive metal tracks crushing the dry desert dirt as they approach the dead wellhead. The sharp excavator bucket bites into the earth, digging a deep trench around the twisted metal casing to expose the undamaged pipe. We need to dig down several meters to find solid and uncompromised steel where we can safely attach our heavy cutting equipment. The skilled operator handles the massive machine with surgical precision, carefully avoiding the highly pressurized mud column still resting inside the pipe. Tons of heavy dirt and rock are moved out of the way, revealing the true extent of the underground structural damage here. The severely deformed wellhead is now completely exposed, standing like a defeated giant in the center of the newly excavated dirt crater. Specialized heavy cold cutting machines are brought into the trench. We cannot use standard blowtorches due to the lingering risk of gas. The advanced cold cutter uses a high-pressure stream of water mixed with abrasive sand to slice cleanly through the thick steel. It is a slow but incredibly safe method. The abrasive water jet easily cuts through the metal without generating any dangerous sparks. The damaged top section of the ruined wellhead is finally severed. A massive crane slowly lifts the heavy and twisted metal away. We now have a completely flat cut on the main casing pipe. The well is finally ready for the plug. Heavy cement trucks arrive at the site carrying a specialized and rapid setting concrete mixture designed specifically for capping deep oil wells. This special concrete must withstand immense geological pressures and highly corrosive underground environments for decades to come without degrading or cracking ever. The heavy liquid cement slurry is pumped directly into the open casing, displacing the top layer of the heavy mineral mud inside. The thick gray concrete fills the pipe, creating an impenetrable and rock-solid plug that will permanently seal the volatile reservoir underground. Dedicated workers carefully trowel the top of the cement plug, ensuring a perfectly smooth and completely sealed finish on the metal casing. A heavy, solid steel cap is finally welded over the concrete-filled pipe, providing a secondary layer of absolute security and protection. The bright welding sparks fly into the darkening desert sky, signaling the successful completion of an incredibly dangerous and complex engineering task. The massive excavators return to push the excavated dirt back into the crater, completely burying the sealed wellhead under tons of earth. The desert landscape is slowly restored to its original state. The dangerous industrial scar on the surface is now completely erased forever. The heavy demolition equipment is loaded back onto the massive transport trailers. The crew is exhausted but incredibly proud of their work. This intense operation proved the incredible skill and absolute bravery of these specialized demolition workers operating in truly harsh and unforgiving conditions. They successfully faced down thousands of tons of volatile subterranean pressure and quickly neutralized a massive threat to the local environment today. It is a perfect combination of advanced engineering, precise mathematical calculations, and pure, unadulterated human courage in the face of extreme danger. The bright sun begins to set over the Avaz oil field, casting a beautiful golden glow over the quiet and secured landscape. The incredibly roaring beast beneath the earth has been silenced forever. The massive oil reservoir is safely contained deep beneath the surface. Our dedicated crew packs up the final pieces of gear, ready to move on to the next major industrial demolition challenge tomorrow. The entire world relies on these hidden heroes to clean up massive industrial messes and prevent catastrophic environmental disasters from happening globally. We finally leave the Avaz Desert behind, knowing that another highly dangerous oil well has been safely and permanently decommissioned for good. Thank you very much for joining us on this incredibly intense journey into the dangerous world of high-pressure, well-killing operations. This is the Demolition Worker channel. Proudly signing off. Stay tuned for more extreme engineering, massive machinery, and incredible destruction next time.